Welcome again, guys. In the previous tutorial, I managed to teach you about the stationary points. Now in this tutorial, I'm going to help solve this question on the whiteboard here. The question reads, identify stationary points on the curve y equal to x cubed minus 3x plus 2. For each of the points, determine whether it is a maximum, minimum, or a point of inflection. So the previous video I told you that at stationary points, the gradient function, that is dy dx, is always equal to 0 at the stationary point. So the stationary point, it can be a maximum point, it can be a minimum point, or it can be a point of inflection. So we are going to differentiate this given function with respect to x. So the function given is y equal to x cubed minus 3x plus 2. Now, first derivative dy dx is equal to, differentiating this part becomes 3x squared, the part reduces by 1 minus 3. So this we equate it to 0 because it is the stationary point that we are trying to determine. Now 3x squared is equivalent to 3x squared minus 3 is equal to 0. So factoring out 3 here, we got 3x squared. So 3 is common, 3 into bracket x squared minus 1 is equivalent to 0. So at this particular point, when you find the value of x here, you're going to obtain the two values of x because the highest power here, the highest power of x is equal to 2. So we need to get the two values of x. So the values of x here that you're going to obtain is either going to be the value of x is using the quadratic formula is equal to positive 1 or a negative 1. So x either is positive 1 or a negative 1. Now, if the value of x is positive 1, how do we get the corresponding value of y? So we come and say when the value of x is equal to 1, the corresponding value of y, we're going to use the equation y equal to x cubed minus 3x plus 2 to get the corresponding value of y. So this becomes 1 cubed minus 3 into bracket 1 plus 2. So this is 1 plus 2. So the value of x here, this one x cubed y equal to so the value of y here, this one is going to be 0. So the first coordinate of the stationary point is going to be x comma y. So it is 1 comma 0. So this is the first stationary point. Now the second stationary point, the two values of x were either 1 or negative 1. So we come and say again, when x equal to negative 1, the corresponding value of y is equal to x cubed. So that becomes negative 1 into bracket cubed minus 3 into bracket negative 1 plus 2. So this gives you the value of y to be equal to 4. So the stationary points we have negative 1 comma 4. So we got two stationary points, this one 1 comma 0 and negative 1 comma 4. Now we want to determine the two stationary points, whether it is a maximum, a minimum, or a point of inflection. Now we just go to the next page. So we're going to start with the first point. The first point was 1 comma 0. So starting with the point 1 comma 0, how are we going to do it? We can say we are going to have such kind of a diagram. Now the value of x here, because we are going to relate to the x-axis, we want to test for the maximum, the minimum, or the point of inflection. So we're going to have, so we're going to have a horizontal line running this way. that is so here we got an x, this side we got an x, we can have the x here is 1, x coordinate here is 1, so we put 1 at the middle. Now from the number line, if this is the number line, if we have 0, 1, then we have 2. So the number to the right, to the left of 1 is 0, and to the right of 1 is 2. Now I want to find the dy dx, the gradient function now. The gradient function was this dy dx. dy dx was equivalent to 3x squared minus 3. So this was the gradient function. Now at where x was 1, the gradient function was equal to 0. dy dx. When you substitute 1 in this equation, I'm going to get dy dx to be equal to 0. So the nature of the curve, it is going to flatten. Now we come at x equal to 0. What is dy dx? So you substitute here x equal to 0 on the gradient function. So it is 0 squared multiplied by 3 is 0 minus 3. So this one becomes minus 3 dy dx. So minus 3, the nature of the curve of minus 3, top left, the bottom right. This is the nature of the curve. Then we come to 2. When x equal to 2, when you substitute these 2 in the gradient function, dy dx becomes 2 squared, that is 4 times 3. That is 12 minus 3, 11. 12 minus 3 is 9. So this one becomes 9. The gradient here is positive. If the gradient is positive, it is going to run this way. So the curve tends to take this particular shape because it is from the left, top left, it goes downwards, then it tries to flatten, then it is curving upward again. So this kind of curve, so this particular point, because the curve is like a basin, so this one is called a minimum point. It is now a minimum point. You have determined the minimum point, the first point. The second point of the curve, the second point or stationary point was -1, 4. So again we come and determine this particular point. So we got x and we got dy dx. We got x, we got dy dx. Then we have the 3 points. So the first value of x here is -1. So we're going to put that -1 in the middle. Then we have the other points coming. So this -1. Then you come to the number line again. You remember that if -1, we got -1 here. The next number to the left is going to be -2. Then we have -3. The number to the right of -1 is going to be 0. So we got -1 in the middle. Then we have 0 here. Then we have -2. Again, we come and substitute in the gradient function, which is dy dx was equal to 3x squared minus 3. Now, let's start with this one. At x equal to -1, the gradient function, this one substituted becomes 0. So the nature of the curve here, it flattens. Now, where x is equal to 0, we substitute in the dy dx where x is equal to 0. So this one becomes -3. The nature of the curve is this way. This is the nature of the curve. It's a negative gradient. Where x equal to -2, we want to find dy dx. So this one -2 squared, we got 4 times 3 is 12. That becomes a 9. 9 is a positive gradient. So how the curve runs is this way. So this curve tends to run this way. This one is the positive, then flattens, then the negative. So this kind of point is called the maximum point. So this is the maximum point, and that's how we find the nature of the maximum and the nature of the minimum point. Subscribe for more updates. Thank you.